Today we're going to start Unit 3 with parallel lines and transversals. Now, parallel lines, this is a word that you heard of back when you were in 6th and 7th grade quite a bit. Parallel lines are two lines that will never cross, they will never touch. They are the same distance apart as they go on forever. Parallel lines. I'm going to use the lines on my paper because they are a perfect example of parallel lines. And a transversal is a line that intersects parallel lines. So, definitions, parallel lines are lines that are equidistant apart and because they will never cross, never touch. And a transversal is a line that intersects those. A line that intersects parallel lines. Now, when I have a set of parallel lines and they're intersected by a transversal, that creates 1, 2, 3, 4, 5, 6, 7, 8 angles. 4 up here and 4 down here. 8 different angles. So 8 angles are created. Now, when we talk about these angles, we're going to talk about them in terms of their position, and to do that, we need to learn some vocab. As we go through this vocab, I'm going to be referencing these numbers that are on the diagram. These numbers can change places. They're not always going to be numbered in this order, but for the sake of our descriptions of their position, I'm going to reference back to these numbers. So, the first type of angle that we have created are called vertical angles. Vertical angles are angles that are across the vertex from one another. So if I look where this transversal crosses this parallel line, that point right in the middle where those lines cross, that's a vertex. So if I look diagonally across the vertex, those angles are vertical angles. So some examples of vertical angles from this diagram are angles 1 and 4. Angles 1 and 4 are across the vertex from one another. Also across the vertex from one another are 2 and 3. If I look at the bottom set of angles, 5 and 8 are vertical, 6 and 7 are vertical. They're across that vertex. Those are vertical angles. If two angles are vertical, they are congruent. Vertical angles are congruent. Remember, congruent means they have the same measure. So vertical angles are congruent. They have the same measure. The next vocab word we're going to look at are adjacent angles. Adjacent angles are angles that are right next to each other. So if I go back to my diagram, let's write that down first, next to each other. If I go back to the diagram, and I'm going to start with number 1. Number 1 is next to number 2, and number 1 is also next to number 3. Number 8 is next to 6 and 7. Angle 5 is next to 6 and next to 7. It's not next to 8, it's actually vertical to 8. So next to it means it's touching it. It's side by side. So some examples. Of adjacent angles would be angle 1 and angle 2. Angle 1 is also adjacent to angle 3. Angle 7 is adjacent to 5. And angle 7 is also adjacent to angle 8. Now, obviously, these are not all of the adjacent angles. I just wanted to give you a few examples. Side by side, they are adjacent. Now, adjacent angles are not congruent. These two angles are not the same. They're not the same measure. There's going to be a different relationship that we're going to look at right now, and that is supplementary angles. You may remember this word, supplementary. Supplementary angles are angles that add to 180 degrees. Now remember, from previous units of study, 180 degrees forms a straight line. So if I were to take this line and break it into two angles, those are supplementary angles because they form that straight line, supplementary. So if we look back at our diagram, I form this transversal on the bottom, this parallel line on the bottom. 5 and 6 create a straight line above that parallel line. They are supplementary angles. They also happen to be adjacent. Angles 7 and 8 create a straight line. They also happen to be adjacent angles. I can look along the transversal. 2 and 4 make a straight line. They're adjacent, but they're also supplementary. 6 and 8 are adjacent and supplementary. I can look on the other side of that transversal as well. 1 and 3 are adjacent. They create a straight line. They're supplementary. Same thing with 5 and 7. So there's lots of different supplementary angles that we can consider. If I were to write down a couple of examples from our diagram, I'm going to use, how about 1 and 2 along the top of that parallel line. Angles 1 and angle 2 are supplementary, but also 1 and 3 because they form the straight line, which is the transversal. I'm going to flip my page over so I can keep going with these notes. I'm actually going to just slide another page on top so I can keep using that diagram. Another important vocab word is corresponding angles. corresponding we talked about a lot when we were talking about corresponding sides and corresponding angles for different figures that we were doing when we were doing transformations. So corresponding angles are in the same spot. If I were to look at another set of parallel lines in a transversal, just so I can draw on it. I have angles that end up being in the same place. If I use the numbers from this top diagram, angle 1 is in the same place as angle 5. It is on the top of the parallel line on the left-hand side of the transversal. Angle 2 is also on the top of that parallel line, but it's on the right-hand side of the transversal. Angle 6 in the diagram is in the same spot. Angle 4, sneak that in there. Oh, that wasn't 4 on my diagram, it was 3. Angle 3 is in the same spot as angle 7. And 4 is in the same spot as 8. So it's kind of hard to tell, my numbers are snuck right in there, but if I were to take a piece of patty paper and I were to trace my angles, 1, 2, 3, 4, and I were to slide them down on top of the second set of angles, I can see that they match up with the other 4 angles down below. 1, 2, 3, 4. They match up with 5, 6, 7, and 8. Because they match up, because they're in the same spot, that makes them corresponding angles. Corresponding angles are congruent. Meaning they have the same measure. So let's try an example. We'll use this to do an example that comes out of your textbook. You're given a set of parallel lines that are cut by a transversal, intersected by a transversal. And when it intersects, it makes a 70-degree angle right here. And our job is to fill in all of the other angles. And if we know one angle, we can do that. Now, I'm going to slide my vocab terms right over here, at least the word. Now, I want to describe how I know the measure of these angles based on these vocab words. So if this angle right here is 70 degrees, I know that the angle vertical to it is also 70 degrees. If it's across the vertex, it's congruent. If it's across the vertex, it is also 70 degrees. I now know 2 of the angles on my upper half of my diagram. Those 2 angles correspond with 2 of the angles down below. Just doing a quick little sketch on my paper. If I take my patty paper and I slide it down to the second set of angles, I can see that it corresponds, they're in the same place as these two angles. Because they're corresponding, those are also 70-degree angles. I have 4 angles that are 70 degrees. I have 4 unknown angles. But I know that angles that are right next to each other that form a straight line, adjacent angles that form a straight line, are supplementary. That is a straight line. Because it's a straight line, together they will equal 180 degrees. So if I take 180 and subtract 70, that will give me the measure of the angle that's missing, which happens to be 110. Because these are supplementary, this angle must be 110 degrees. If this is 110 degrees, its vertical angle is also 110 degrees. And you notice that together, these two also make a straight line. They're 180 degrees. These two 110 degree angles correspond. They're in the same spot as these two angles down below. So using a few of these vocab terms, I'm able to determine all of the other missing angles. Let's try one more. I'm going to change the orientation of my parallel lines just so we see it in another light. Let's have them go straight up and down. And we'll make our transversal go this way. Now, again, you can say I have 1, 2, 3, 4, 5, 6, 7, 8 angles. Some of them are obtuse angles. Some of them are acute angles. Let's say that this one is, how about 92 degrees? 92 degrees. I always like to start with vertical angles. I think they're the easiest ones to pick out. They're across from one another. They're vertical across the vertex. So if I look diagonally from 92 across this vertex, I know that this is its vertical angle, so it's also 92 degrees. If these two angles are 92 degrees, they correspond with 2 other angles that are also 92 degrees. I'm going to finish finding these 4 angles over here first, though. Now, if this is 92, I know that together with this angle over here, it has to form a straight line. It's going to form a 180 degree straight line. Do you see that? This straight line right here. So 180 minus 92 should give me that missing angle. Sorry about all the marker on the paper. $88 degrees. If together these make a straight line, this must be 88 degrees. Notice that these also form a straight line and they equal 180 degrees. If this is 88, this must also be 88. Again, another 180 degree straight line. I now have the 4 angles for the left-hand side of this diagram. I'm just going to match them up with their corresponding angles on the other diagram. 92, 92, 88, 88. So once you have one angle, you have all of the information you need to find the other 7. Be sure to add this page of additional definitions to your interactive notebook. We have transversal, that's the line that intersects the 2 parallel lines. Corresponding angles, angles that are in the same spot. Supplementary angles, 2 angles that are side by side, they add up to 180 degrees. vertical angles across the vertex from one another. But we've added a couple of new definitions. We have alternate interior, alternate exterior, and consecutive interior. Now, when we're talking about interior and exterior angles, interior means inside. The only thing that we can be inside of on this diagram is the parallel lines. So inside the parallel lines is in here. Outside, exterior, is out here. Do you see the difference? Inside the parallel lines, outside of the parallel lines. Interior, exterior. Now, the key word is alternate. They're on opposite sides of the transversal. So exterior angles, and then I have to go opposite sides of the transversal. Opposite sides. Same thing with interior. If this is one angle, this is the opposite side of the transversal. Alternate interior. Same side interior would look like this.